Another straightforward example. A car valued at $10,000 depreciates by 10% per year, and we need to find the value of the car after 1 year. This is a percentage decrease question. The rate is 100% minus 10%, or just 1 minus 0.1 equals 0.9, and the progression is again very easy to write. In this example, T0 is $10,000. Again, not T1, which would be the amount after 1 year. Before we do any calculations, the initial amount is T0 equals 10,000. You don't need to set this up using your ClassPad to find the amount after 1 year. It's simply 0.9 times 10,000, which gives a value of $9,000. Another application is the idea of growth and decay. A growth and decay situation involves an amount increasing or decreasing at an exponential rate. These situations can be modelled by geometric sequences as we are repeatedly multiplying by the percentage change. Example 5. $2,000 is invested and accrues interest at a rate of 9% per annum compounded annually. Write down a recursive rule for the amount in the account at the end of year N. Here it is. So once again, the effective percentage increase is 109%, or 1.09, and we're multiplying that by the previous term. So Tn equals 1.09 times Tn minus 1, where T0 equals 2,000. We can also write it as Tn plus 1 equals 1.09 times Tn, and remember we're just adding 1 to each index value for the terms to work out that change. This second statement is the ClassPad friendly form. Remember that ClassPad wants to use a n plus 1. Part B, if no further deposits are made, how much will be in the account after 10 years? So once you've entered this into your ClassPad, look up T10 and you'll get the answer. Part C is easily done. You just look up your table on your ClassPad to see when the value reaches $5,000, and you'll discover it takes 11 years to accrue enough interest to reach $5,000. Example 6 is a depreciation example. We have a house depreciating at 15% per year, and we're looking at a term of 5 years with an initial value of $10,000. It's a geometric progression. The interest rate effectively is 85%, or 0.85. So the sequence is simply written like this, and the initial value is $10,000. After 5 years, the ClassPad gives $4,437.10. Other financial applications involve recursion. Example 7, Meg currently has $2,000 in an account. Her grandmother gives her $200 every Christmas, and she adds that money to the account, which receives or accrues interest at a fixed rate of 6% per year. Write down how much money is in the account initially and at the end of the first, second, and third years. Okay, so we start with $2,000. She's adding $200 to it every year, and she's earning 6% interest per year. So the following year, the value of her investment will be 1.06 times whatever the value was for the previous year. That's 106% of the previous year's value. But she's adding $200 to the amount before the interest is calculated. So we bracket Tn plus 200. And the initial value is $2,000. Now all of that can be put into your ClassPad, and you will get these three values for the first, second and third years. I do hope you are taking your time to set this up in your ClassPad to check that all these values are in fact correct. Finally, how much will be in the account at the end of 10 years? Well, again, ClassPad makes it very easy. The answer is $6,376. Walkies! Alright, I'm coming.